Hi everyone, my name is Anna and this is Javi, and we both work for a company called 47 Degrees with offices in Seattle, Washington and San Fernando, Cádiz. We specialize in several and diverse technologies, from big data backends and Android app developing with Scala to Swiss-powered iOS app. We are really passionate about improve our code quality, and we love to have fun too. We are come all the way from Cádiz to Logroño to talk about functional programming and what benefits it brings to our daily Swiss developing. And also will you to introduce second bridge. We have it's a framework we have created that bring many features and data types from the Scala languages to our iOS app that can make your coded development process cleaner and easy.
Yeah, okay. Well, functional development, functional programming is nothing new. Its origins come from the late 50s. So you can imagine in so many years there's a long list of functional programming languages. In this slide, there's a small selection of the most important pure functional programming languages. By pure, we mean those that don't have any imperative traits. And most of them are used mostly in math and calculus applications. But if we add to the list languages that are oriented to functional programming but do have imperative traits to a certain extent, the list grows longer. And historically, languages like Lisp and some of its dialects, like Scheme, Common Lisp, have had a great impact throughout computer science history. And in recent years, languages that are more modern, as Scala and Clojure, are being increasingly used by also companies for several industry applications. And what about Swift? What happens with Swift, the new guy in town? Does Swift fit into all these functional programming languages? Is worthy of this exclusive club? We'll see a bit later. But first, let's discuss why functional programming is getting so much attention in recent years. Because I don't know about you, but for me, 20 years ago, it's something that I will read in my college books, or maybe I will learn Lisp for a research paper or whatever. But in recent years, as I said before, modern languages as Scala and Clojure are being used more and more by several companies for several reasons. And one of the reasons is that functional code tends to be cleaner, easy to maintain, more reusable, and extremely well testable. And for those reasons alone, and for others that we will see in the next few slides, functional code tends to work really well in multi-threaded environments. And nowadays, multi-threaded environments is almost everything except Arduino boards or whatever. But if you have an iPhone, an iPad, a laptop, or a big server with 30 nodes or whatever, this is multi-threading. And it tends to work really well, and that it's awesome.
In this list, you can see the most foundation block of functional programming. Some of them are already available in Swiss more or less easily.
Yeah, the first of them is something that we've been really demonstrating for in the days of Objective-C. It's something that many languages had many years ago.
Languages that want to be more functional need to treat a function as another data type. That means that we should be able to pass function as parameter other function or to return function from another function.
Yeah, you notice in the examples, well, the first one is really simple. It's just a function that takes another function that returns strings. So the only thing we're doing is returning the result. So we can call this print result function, and we pass a function to it, and we'll print whatever this other function prints. The other one is a little bit trickier, and it takes an integer as a parameter, and what actually does is to create functions that multiply a number by the integer we pass on as a parameter. So we are actually creating multipliers. So if we want to create a function that multiplies by 2, we just call create multiply and pass 2 as a parameter. So this is what we're doing with the twice function. So this is something that's really important for functional programming, as we see later. Sorry.
Well, in summary, other thing we can do with an integer should be able to a function.
Yeah, so once we have that, we can use functions as we do with an integer. We have access to higher order functions. And a higher order function can be a function that returns other functions, we will see before, but usually it's a function that among its parameters take a function and other stuff, and usually return the result of applying this function to the other parameters in several ways. So there are several standard and really important higher order functions in every functional language, and in Swift some of them are already available in the standard library. You will recognize maybe map, reduce, filter, and anyone has used it. So, and in later versions there's support for flat map, but there are other ones already available in Scala and Haskell and other languages that are not available yet in Swift. So, pure functions. By pure, we don't mean anything discriminatory. We are not from Slytherin. Actually, we mean by pure functions, functions that always return the same stuff when they get the same set of parameters, which sounds logical, but usually it isn't. So, for example, you've noticed the left part of the slide, this encounter function is taking a counter which is outside its scope, and is modifying to increment it. So if we're using this is cool and nice, but someone on the outside could modify this counter on another thread or whatever. So this could get dangerous, and it's difficult to test, because in our test we should mock this counter variable, and if we have problems because someone is modifying the variable, it's difficult to debug. And we can modify it, as you can see in the right side of the screen. And with what we actually have done is to get the counter as a parameter, and once we execute this count by function, it will return a new version of this counter incremented. So no one on the outside is going to modify the data we're working with. So we're pretty sure that this is going to do whatever we want. It's not dependent on the state. So it's easier to test because we are not depending on anything outside the function, and it's easy to maintain because it's less error prone.
In functional programming, recursion is the most general and usually the only way to loot. Functional language considered impure can also use the traditional for or while loop. But this is something usually discouraged. In summary, we use recursions when a function calls itself. In this example, can you see calculate the Fibonacci sequences by performing several recursive call itself.
Okay, so recursion is cool, but it has a weak point. If we perform several recursive calls to a function, we need to store the intermediate results in memory. So if we perform a recursion over, I don't know, an array of 1 million items, you can get to a Stack Overflow because you're filling the memory. So one way to avoid this problem is to use tail recursion. It's a one way of performing recursion that can be optimized by compilers to avoid this memory problem. But unfortunately, it seems that even the latest Swift version doesn't guarantee that tail recursion optimization is in place. So it can be optimized, it can't be, you don't know. So we have to be really, really careful while using recursion in our Swift projects. And another foundational block of functional programming is immutability, and you can see here the Japanese word for immutability is fuhan, and literally means change that if you dare. Well, not really, but this is more or less the concept. Immutable values can't change. So this goes beyond just using constants in a Swift code. When we have immutable data types, that means that when we modify immutable data, it will return new copies of themselves. So imagine you have an array. In this example, we're imagining that we have an immutable array that has 5 items, and we want to add an item to it. So if it's a constant, we can't modify it. So what is going to happen is that when we perform the append operation, it's going to return a new copy of this array with the extra element we're adding. So we're pretty sure that the data we're working with, it can't be modified by another thread or whatever. So if we check the last line, we're checking that the original array is 5 items long. So it hasn't been modified. So this is also called a referential transparency. And once our functions are referentially transparent, it means that our data is totally safe in a multi-threaded environment. And as data is made of constants, they can be shared among the different copies, so it's not a waste of memory. So once we have functions that always return the same stuff when we pass the same parameters to it, and these functions work with immutable types that can't be modified on other threads, as we've seen before, it means that our code is going to live safe and happy in islands of code, totally independent of each other. So in a multi-threaded environment, this is a great news, because we're pretty sure that other threads are not going to interfere with our work. And it means that we don't need extensive mechanisms of control as we used to while working with concurrency in other languages. So we're really happy with Swift. Swift is great. Swift is been really an improvement over Objective-C. For example, we love the data type system. Is totally type safe. It's enforcing constants, which really helps with achieving immutability. And it has other advanced stuff we haven't talked about yet, like partial applied functions, like pattern matching that really works over the switch blocks from C. But for us, it's not enough. They use constants help to achieve immutability, but there are not real immutability types in the standard library. Pattern matching is nice, but for us it's really great if a block, a switch block, could return a value like pattern matching does in Scala language. And also, not having child recursion optimization guarantees is really, really sad. We are developing a second bridge to try to cover these cuts. We are basing the development of this framework on other framework called SwiftSet, but adding new feature, real data type, partial functions, and improved pattern matching by returning a value. Second bridge is currently on developing, is totally free to use, and it's open source. That means that you can use in your projects and also contribute code it. We really love it. You can learn more about these assets in the repository by opening this URL. You can see. Second bridge, several immutable versions of really useful data types. They are words gray as constant and return new system when modified. The first of the immutable data type available is implementation of the single link list. As you can see in these examples, we have created a new list of integer with 4 elements. And then we use the tail function that returns all elements except the first one.
continue, we are checked the size of the list, and the result is 4 as expected. The next one was an immutable implementation of the array. In this example, we are just creating a new array for 6 elements. And like before, operations won't change the original ones, but will create a new versions. And stack is the same. Math are similar as with dictionaries, but not only they are immutable. They allow different data types for case as in math scale. You can see in this example different case. The first is in a string, next int and float. And contains several question operators for improved usable. You can see add and remove. We also tried to experiment a little bit and implement the first switch version of a mutable persistent bipartite vector trait, which is really creative data structure coming from Glacier or Scala. It has near constant complexities in practical operations, and is worthy to share out.
Yeah. And one of the things we really love is that Second Bridge keeps growing and other developers to contribute to it. So one of the things we've implemented is 2 really easy to conform to protocols that are based on Scala's traversable and iterable traits. And what these 2 guys do is that if you're planning to create a new data type and you conform to these 2 guys, you will get access instantly to 40-something really useful utilities that are based on its Scala's counterparts. And other functional programming also implement these guys. So these are several groups of high-order functions and functions with uses from mapping and filtering collections and grouping and partitioning collections too. So there are more than the ones are in this list. So you should check out if you're planning to create new data types. So another feature from Scala we've implemented are partial functions. A partial function is a function that only can be executed on a certain set of parameters. So, for example, if you have an operation that is forbidden for a parameter, typical example is the division by 0, you should use a partial function. By themselves, maybe they don't seem really useful, but one of the things we can do with them is combine them using 2 operators, the OR operator and the AND then operator, to create a small algorithm-like functions. So in this example, we have 2 partial functions. One of them can double every even number we pass on them, and the other guy can triple every odd number it receives. So one thing we can do is to group them. So we're using this OR operator to create a function that if it receives an even number, it will double it. And if it receives an odd number, it will triple it. So by itself, it works great, but we can keep chaining operations. So in the next line, you'll see that we're using this and then operator. So whatever the result of the previous operation is, it won't matter. It will increment it by 5. So this is just a math operation, but we can achieve really complex algorithm-like functions by chaining these operators by themselves. So once we have these functions, we can use the apply methods to receive the corresponding results. But the coolest thing, I think, in my opinion, that we can do with partial function is to have a pattern matching system that returns values. So the switch block from Swift is great, but one of the things we miss from Scala is to have a pattern matching system that returns stuff from it. And this is really important in functional programming because everything is supposed to return things. So every operation can change from the previous ones. So we're creating this pattern matching by using this match function. It will take a variadic number of partial functions. So in this example, there are 2, but it could be 10 or whatever. So once we have this list of partial functions, we can use this apply method to pass parameters. So what match is going to do is to try to find a partial operation that is compatible with the values we've passed to it. So it's going to look up from the beginning to end all the partial functions we specified. And once it finds one that is compatible, it's going to execute it and return the value. So it's one way we found to match to Scala's pattern matching system, which is really, really powerful in functional programming compared with switch blocks in Swift. Second bridge, I hope you don't love it after the talk. And it comes bundled with several playgrounds. So you can see several examples of the features we've just explained, and other ones we don't have time for them. So you can play with them, you can experiment, change things, and I think it's the best way to start to learning these new concepts that may be new to you. So once you download a second bridge, please start from here and you will see. So you can take a look about it's in another screen. So, okay. So we have, this is the second bridge project. So this is our code and the pods and stuff. And these guys are the playgrounds. So you can see there are some documentation and several uses, how to create a vector, for example, how different ways to create them, and how to get data from it, and that we can iterate. So several small and simple examples, so you can get a grasp on it. So for example, the maps, all the things you can use as keys, and all the custom operators we have implemented. So it's a great way to just to get a little flavor on what these functions are doing. Not only with the data types, partial functions are here too. So there are several other stuff that we haven't talked about, like the group by function and other stuff that may be useful. And also we have here this. This is our way to try to explain how functional programming can solve problems. So this is the typical n-queens problem, where you try to fill a chessboard with queens and they don't have to kill each other. So this is one way that we implementing these algorithms by using functional programming. And we have our chessboard here, so you can play and try to modify the algorithm and see what it comes by. So it's a great way to start with functional programming and using second bridge in your projects. So, okay.
Okay. We have invested a lot of time in second bridge, not only to learning functional programming, but also to make it more accessible to our daily Switch developing. As this is completely open source project, to contribute you just to have access or repositories. We are looking forward to your PRs.
Okay, so we hope we have lightened the spark of functional programming inside of some of you. And if you're interested in functional programming, we'd love you to come to Lambda World. It's going to be the largest event about functional programming in Spain. And it's going to sport 2 tracks with several conferences and workshops from real rockstar speakers, not like us, real rock stars. And it's going to be held in the beautiful city of Cádiz, and we don't mean that because we're from Cádiz, it's really beautiful. And it's going to be held this October 24th. And so we have several rockstar speakers, conferences, and workshops, great food and great weather, so what's to miss? So if you're interested, just go to this URL, or come by later and we can give you all the details about it. So if you have any question, answers, and you want to give us cookies, we welcome it. Any question?
Hey, there's a lot of really great stuff here. Thank you so much. I'm particularly excited to see persistent data structures making it to Swift. I have a couple of design questions. I'm curious why you chose to re-implement array in particular, given that Swift's array already is immutable.
But arrays in Swift, I think if you have a constant array, you can add stuff to it, you can remove items from it. So it didn't make sense because even Objective-C arrays, NS array, you can make them immutable and you can make them to create copies of themselves. So for what I know, you can do that with a constant array. So
if you put an array in a constant slot in Swift, then there's certain methods on array which you can't call because they're marked mutating.
These are mutating operations.
I see, and so it's less composable. Is that the concern?
Yeah, I think you can't add an item or remove items from a constant array.
Yeah, there's no method that's like an array by appending item. You'd have to put it in a variable slot, and then the value wouldn't itself be mutable, but the slot would be mutable.
You're actually mutating the value. So
you're not mutating the value, but you're mutating the slot that holds the value. So
anyway, so another thread could come and modify this. Imagine you're working with an array of stuff. So if you're making it variable, someone on the outside could come and modify it. So you're not creating
there are value types, remember. I mean, arrays are value types in Swift. So single owner. But okay, so my second question was about partials. Yeah. So why did you choose to represent partials with a novel data type rather than using optionals?
Sorry, could you repeat?
Why did you choose to represent partials with a novel data type rather than representing them by functionals which return an optional result?
Yeah, it was our way to actually partial functions. We didn't implement it by themselves, but to achieve the pattern matching system we created. So
I see. Because if you implemented partials,
it was a tool to achieve this pattern matching system. So, by themselves they're useful, but it was our tool to achieve that.
Cool. I see how you can't do pattern matching with a function that returns an optional result. Yeah. Okay. Cool.
But it will be a great solution anyway. So thank you. So any other question? Yeah.
So this is really exciting and really cool stuff.
Thank you.
Especially, like Andy said, the persistent data structures are super cool. I'm curious if you have looked at the performance of them contrasted to Swift's array and map types, and then also contrasting the memory usage of the two. Because the big one of persistent data structures is sharing, right? So I'd be curious what kind of differences you actually see in usage there.
Yeah, for most of the types, I think the performance is mostly the same. But actually, we talk about when we creating the vector, the persistent bit partition vector trie, we were talking about experimenting because Scalas, our company usually works with Scala. So Scala's vectors work really, really great compared with Java arrays. But Swift array, it turns out that it's incredibly fast. So you will see if you download our library, our framework, we have a specific test target for the vectors to try to compare how it feature against the array. And the array tend to be equal or even faster than the vector. So we are talking that vectors are an experimentation on how it could be done in Swift. So more or less the same, but arrays tend to be faster than the vectors, for example. So
yeah, that makes sense. Do you have any sense about memory usage between the two?
We haven't tested really thoroughly, but for the not so intensive tests we've done, it's more or less the same.
Okay, thank you.
First, congratulations for your work.
Thank you.
It looks great. I've had two questions. The first one is, how is functional programming related to reactive functional programming? Because we are now seeing how this concept comes, and I'm not sure how it's related.
Yeah, well, I'm not really an expert on reactive programming. I only taken some classes, the typical course on Coursera. My colleagues in my company are really experts in reactive programming, so they could answer better. But I think they're pretty intermingled with each other. So yeah, they're not the same, but usually reactive applications tend to be more oriented towards functional programming. But reactive is more about having signals. And, for example, in the case of an iOS application, it will be, for example, the user touches and other stuff we can do with the UI. You will specify that as signals that will be updated in real time. So you're going to have listeners throughout the code or delegate methods to respond to them. So, but I only know I'm a newbie about reactive programming, so I can answer your question truthfully. So I hope so. But
and the second one is you showed to us some samples, quite simple.
Yeah.
And I think we understand that, but when we are trying to understand functional programming in real world, we don't know how to apply all of those samples in real world problems. For instance, how do you use curry functions in real world to solve one real world problem?
Curry functions.
Curry functions.
Yeah. For example, partial apply functions are great in the case when you need to, for example, to store a value or taking, for example, in the case of an iOS application, imagine you want, there's something in Scala called implicits. I don't know if you know about implicits.
Yes, a little bit.
So it could be a way to achieve implicits in an iOS application, because you could have a partial apply function, and the first set of parameters could be implicit values you could select, and then the result of this will store this configuration. So in the next run of the function, you could take these implicit values to do any configuration or whatever. So it could be an use of it. So in the case of an iOS application, it's difficult to talk about a functional application. So, for example, in a Scala application, the structure of an app is different. So, for example, our colleagues in the company are creating Android apps using just Scala. So what they're doing is mind-blowing, because the overall structure of the app is different. So it's something we can't do yet with Swift, because you still are going to have view controllers and delegate pattern. So we can only select several features of functional programming languages and use it in our code, but it's never going to be a whole functional code, just parts of it. So using, for example, Reactive Cocoa, I don't know if you know about that library, and using Second Bridge or Swift Set or other frameworks about functional programming, you could achieve something similar to it. But for me, it's my personal opinion, it's never going to be, at least in the current state of Swift, functional code by itself. So it's near functional, but it's not completely functional. So yeah, it's more or less what I think about it.
Okay, thank you.
Another question around? Okay, no one is giving us cookies yet. Hi.
Dois. Okay, I don't know if I can speak with the microphone, but I'll try.
Okay.
Okay, so it looks fantastic. Very cool job. Congratulations.
Thank you.
I'll give you a cookie later on. Okay, my question is, just a few weeks ago, I wanted to use Argo to get some JSON from an API.
Yeah.
So it had a very different syntax, very functional programming syntax,
yeah.
And I needed to go back to runes and learn all the new operators, and I took some time to do it.
Yeah.
Now I'm looking to this. It looks very cool. I want to work with this, but it seems there are lots of other operators that I also need to learn,
yeah.
including some that are actually, for example, the apply operator seems to be doing the same that it's doing in runes, but with some different syntax. So my question is, first, is this on production? Did you try to do this in some app? And if so, what happens when someone new to the team comes and suddenly they need to learn this amazing amount of knowledge to actually be productive?
Yeah, we've only used part of this in a production app, so not completely, because it's still on development. So this is something we want to introduce you to it in case of you want to use it or you want to contribute to it. It's actually growing. It's our little baby. So yeah, and it takes time to learn it, obviously, as any framework, new framework. But it actually, if you are introducing yourself into functional programming, it takes a while to get the hang of it. Actually, Anna and I are still learning. So we know for experience, because our colleagues are more versed in functional programming, it takes a while. We haven't talked about monads. We haven't talked about category theory, and it's even difficult to get a grasp of it. But I think it's worthy. I think you can get, for example, if you're interested on using immutable data types, you can forget about partial functions and the other stuff. I mean, we are not saying that you have to use this all at once. I mean, there are several tools that you can use to make your code more functional, but we don't mean that functional code is the only way to do things. So imperative code is okay, declarative code is okay, and in this case, functional code for me is a great solution. So as it takes a while, I think it's best to get some bits of it little by little instead of trying to see the whole picture, because we don't see it yet. So we're not expecting you to do it. So, but I think it's a great way to introduce yourself. And there are other frameworks, as Swift said, where it comes with Second Bridge, and also Reactive Cocoa. It's another great way to introduce yourself into functional programming and reactive programming. So take your time, be patient, because it's difficult for me, for her, and for everybody. So yeah, but I think it's worthy the effort to see programming by another perspective. So yeah, thank you.
Thanks.
So, anything else?
Thank you.
Okay, 3, 2, 1. Okay, so we're done. Thank you very much.